We've all heard the rumors. The universe is collapsing, expanding, or perhaps even perpetually stuck in a state of eternal equilibrium. But what does it really mean for our existence, and what can we learn from the latest discoveries? The cosmic background radiation, a residual echo of the Big Bang, still echoes through the universe. That's a pretty staggering concept, really. It's as if the universe itself is whispering a reminder of its own origins. This faint glow, about 2.725 degrees Kelvin above absolute zero, permeates every corner of existence. At first, that number sounds absurd until you realize it's the temperature of a typical fridge. But what it means is that the universe is still in the process of cooling down, a legacy of the explosive event that gave it life. The cosmic microwave background, as it's known, is a snapshot of the universe when it was just 380,000 years old. That's younger than the Earth, younger than our sun. It's a time capsule of the universe's earliest moments, and yet it's been here all along, waiting to be discovered. But what does it tell us about the universe's ultimate fate? Does it hint at a grand finale, or is it simply a steady state of eternal expansion? The accelerating universe, a phenomenon that's left many in the scientific community scratching their heads. That's because, as far as we can tell, this acceleration started about 5 billion years ago, and it's still going strong. Now, that number sounds absurd until you realize it's not just a matter of galaxies moving faster and faster away from each other. No, it's more fundamental than that. The very fabric of space itself is expanding, like a balloon inflating at an ever-increasing rate. This is what we call dark energy, and it's a mysterious force that makes up about 68% of the universe's total energy density. That's a lot of energy, and yet we have no idea what it is or where it comes from. Some theories suggest it's a property of space itself, while others propose it's a sign of something more exotic lurking in the shadows. The truth is, we still don't know what drives this acceleration, and that's what makes it so fascinating. So, what would happen if this acceleration were to continue unabated? Where would it lead us? Dark energy, the unseen force behind the expansion of the universe. That's right, expansion, not just the stars and galaxies moving away from us, but the very fabric of space itself. That number sounds absurd until you realize it's been accelerating for billions of years. The implications are profound, but also unsettling. What does it mean for our understanding of the universe's origins? That the Big Bang wasn't just the beginning, but a spark in a vast, uncharted expanse? The more we learn, the more questions arise. What drives this force? Is it a property of space itself, or a manifestation of something yet unknown? The answers, much like the dark energy, remain elusive. But one thing is certain, the universe's secrets are still being unraveled, one mystery at a time. The concept of the singularity is a mind-bending one, often associated with the end of the universe as we know it. But what exactly is it? In essence, the singularity represents a cosmic event horizon, a point of no return where the laws of physics as we understand them cease to apply. That's a pretty daunting idea, and it's not hard to see why some theories suggest that a singularity could be the ultimate fate of our universe. But what's surprising is that this point of no return might not be a fixed location, but rather a dynamic entity that shifts and changes as the universe evolves. That number sounds absurd, until you realize that the distances we're talking about are on a scale that defies human comprehension. The implications of a singularity are still deeply debated among cosmologists, and it's clear that our current understanding is far from complete. So, what would happen if our universe were to reach such a point? Would it be the end of everything, or could it somehow give birth to new realities? The singularity may be a cosmic event horizon, but it's also a mystery that continues to intrigue and unsettle us. The multiverse hypothesis, an idea that's been floating around the fringes of cosmology for decades, but one that's gained significant traction in recent years. It's a mind-bending concept, really. The notion that our universe is just one of many, possibly infinite, others. That's right, many. The number sounds absurd until you realize that each of these universes could be identical to ours, or completely alien. The idea raises more questions than it answers, of course. If we're just one of many, what's the point of it all? Is our existence merely a statistical anomaly, a fleeting moment in the grand tapestry of the multiverse? And what does this say about the concept of end that we've been grappling with? Does it imply that there's no such thing as an ultimate end, only a transition to another reality? The multiverse hypothesis challenges our understanding of reality, but it also leaves us with more questions than answers. What lies beyond the veil of our universe, and what's the nature of this vast, unseen expanse? The problem of time is a peculiar one. We think we understand the universe's timeline, but the more we learn, the more it seems to unravel. Einstein's theory of relativity showed us that time is relative, not absolute. That's a mind-bending concept, especially when you consider the sheer scale of cosmic events. The universe is 13.8 billion years old, but what does that even mean? That number sounds absurd until you realize that's just a snapshot of a single moment in time. The past, present, and future are all intertwined, making it difficult to grasp. The laws of physics as we know them start to break down at the quantum level, and our understanding of time becomes increasingly fuzzy. The question is, can we truly comprehend the universe's timeline? Or are we just scratching the surface of a much more complex reality? The notion that our universe is a self-contained, finite expanse is a comforting one. It's a concept we've grown up with, a narrative that's been reinforced by decades of research. But what if this is an oversimplification? What if the universe is not what we think it is? I've been studying the work of certain cosmologists, and their ideas are starting to challenge my understanding of reality. They suggest that our universe could be just one of many, a tiny bubble in a vast multidimensional space. That number sounds absurd until you realize the implications. Our observable universe might be just a small fraction of a much larger cosmos. And what about the nature of time itself? Is it a fixed backdrop, or is it something more malleable? The more I delve into these questions, the more I'm forced to confront the limits of our knowledge. It's a humbling experience, to say the least. And yet, it's precisely this uncertainty that makes the search for answers so compelling. What would it mean to redefine our understanding of the universe? Would it fundamentally change the way we live our lives? Or is it just a philosophical exercise? The more I ponder this, the more I'm convinced that we are on the cusp of a major paradigm shift. The multiverse hypothesis, a mind-bending concept that challenges our understanding of reality. A universe is born, expands, and eventually succumbs to the forces of entropy. But what if I told you that this is just one of many? The idea of a multiverse, where every possibility plays out in a separate universe, raises more questions than it answers. For instance, if our universe is just one of many, what does that say about the concept of probability? Does every possibility actually exist, or are some just statistical outliers? That number sounds absurd until you realize the sheer scale of the multiverse, where every variation of every event is playing out in a separate reality. But here's the kicker: if we're just one of many, what's the point of our existence? Is it all just a random occurrence, a fleeting moment in the grand tapestry of the multiverse? The implications are far-reaching, and yet we're still grappling with the basics. What does it mean to be part of a multiverse, and how does that change our understanding of the universe and our place within it? The universe's expansion is accelerating, yet we still can't fully grasp its fundamental makeup. Enter dark matter, the mysterious substance accounting for roughly 85% of the cosmos. That number sounds absurd until you realize what it implies. Our most advanced telescopes, the most sophisticated simulations, and the most exacting calculations can't seem to pin down what's actually holding the universe together. It's as if the very fabric of reality is a puzzle with a crucial piece missing. What's more, dark matter doesn't just affect the universe's overall structure, its presence is also felt in the way galaxies rotate, stars form, and even the way our own solar system behaves. The existence of dark matter has been inferred, not directly observed, and that raises more questions than answers. What is this missing ingredient exactly? Is it a particle, a field, or something entirely different? And what does its elusiveness reveal about the limits of our current understanding? The cosmic microwave background, or CMB, is often cited as the most reliable witness to the universe's birth. It's the residual heat from the Big Bang, lingering in the form of microwave radiation that fills the cosmos. That number sounds absurd until you realize the universe was once so hot, it's almost incomprehensible. It's as if the very fabric of space and time was a furnace, with temperatures soaring to unfathomable heights. The CMB is our window into this primordial past, a snapshot of the universe's earliest moments. But what does it really tell us? Does it confirm our understanding of the Big Bang, or does it raise more questions than answers? The CMB's uniformity across the universe is striking, but what about the tiny fluctuations that do exist? Are they a remnant of the universe's chaotic past, or a sign of something more sinister lurking in the shadows? Black holes, the cosmic vacuum cleaners, have long been a topic of fascination and debate. But what's their role in the universe's ultimate fate? That's what we're here to explore. The numbers are staggering. A black hole can consume a star whole, its mass warping the fabric of space-time around it. That number sounds absurd until you realize the sheer scale of these cosmic monsters. But here's the thing. Black holes aren't just destroyers, they're also creators. They warp the universe in ways we're only just beginning to understand. Some theories suggest that black holes could even be portals to other universes, a notion that's both thrilling and unsettling. But let's not get ahead of ourselves. The truth is, we still don't fully comprehend the role of black holes in the universe's evolution. Are they the harbingers of the end, or a necessary part of the cosmic cycle? The universe still holds many secrets, and black holes are just one of the many mysteries waiting to be unraveled. As we delve deeper into the heart of the universe, we begin to realize that the truth is often more complex and more surprising than we ever imagined. The quantum fluctuation paradox is a mind-bending concept that challenges our understanding of the universe. It suggests that even in the most empty of space, tiny fluctuations in energy can pop into existence, lasting for an infinitesimally short time before annihilating themselves. That number sounds absurd until you realize it's not just a small chance, but a guaranteed occurrence. It's as if the universe is constantly deciding to create and destroy in the same instant. This idea raises more questions than it answers. If such fluctuations are a fundamental aspect of reality, what does it mean for our understanding of time and space? Can we truly say we understand the universe if it's constantly shifting and morphing in ways we can't fully comprehend? The concept of a point of no return in the universe's timeline is a mind-bending one. Some theories suggest that, at a certain point, the expansion of the universe will reach a critical velocity, making it impossible for matter to return to a singularity. That number sounds absurd until you realize it's not just a random value, it's the result of complex calculations based on our current understanding of dark energy and the universe's accelerating expansion. What's fascinating is that this point, known as the Big Rip, would essentially be the end of time as we know it, with galaxies and stars torn apart by the growing distance between them. But here's the thing. We're not even close to that point, and yet, it's already had a profound impact on our understanding of the universe's ultimate fate. The question remains, will we ever be able to pinpoint this exact moment? Or will it remain a theoretical construct, a reminder of the limits of our knowledge? One of the most intriguing ideas in cosmology is the eternal return. It suggests that the universe undergoes cycles of expansion and contraction, with each cycle potentially resetting the universe's state to an earlier point. That sounds absurd until you realize that this could explain the observed homogeneity of the universe on large scales. It's as if the universe is a vast, cosmic tapestry, with each cycle weaving a new pattern. But here's the rub. If this is true, what happens to our experience of time? Does it simply reset, or do we get to relive the same moments over and over? The eternal return raises more questions than it answers, and it's a scenario that's still firmly in the realm of speculation. Some theories, like eternal inflation, could potentially support this idea, but others, like the anthropic principle, seem to contradict it. So, what role does our universe play in these cosmic cycles? Is it just a minor variation on an eternal theme, or is it something more? The uncertainty principle is often touted as one of the most counterintuitive concepts in physics. It states that certain properties of subatomic particles, like position and momentum, cannot be precisely known at the same time. That number sounds absurd until you realize it's not just a matter of experimental limitations. The principle itself is a fundamental aspect of the underlying reality. It suggests that the act of observation itself can change the behavior of the particles being observed. That's a pretty profound implication. If our measurements are influencing the outcome, then can we ever truly know what's going on at the most fundamental level? Or are we forever trapped in a web of uncertainty, forced to make educated guesses about the workings of the universe? As we continue to unravel the mysteries of the universe, one thing becomes clear: our understanding of the cosmos is far from complete. Join us next time as we delve deeper into the complexities of the universe and the secrets it still holds.